Michael Oard served as a lead forecaster for the National Weather Service in Great Falls, Montana for 18 years. He has an MS in atmospheric science from the University of Washington and has written many books and articles on meteorology and weather. In The Ice Age, Only the Bible Explains It, Mr. Oard examines the physical evidences, scrutinizes the secular theories of its origin, and shows how the Bible best explains the Ice Age.
Question: what is the last major geophysical event in Earth history? I'll give you one guess in 1 second to figure it out. The Ice Age. Second question: what if evolutionary uniformitarian scientists can't explain the last major event while creationists can? What would that mean? I'll let you think about that while I'm talking. I'm going to be talking about the recent Ice Age, that there was a recent Ice Age. The Ice Age is a major mystery of mainstream science. The climate change caused by the flood resulted in the Ice Age. There was only one rapid Ice Age. There will not be a future Ice Age. I'm going to talk about support for the model in the form of wet deserts. That is where they have evidence of lakes and rivers and streams and now desert areas. I'm going to talk about the lowlands of Siberia and Alaska and Yukon are unglaciated. This is a mystery of mainstream science. I'm going to just briefly touch on an area I've worked on for about 15 years, the woolly mammoths in Siberia, Alaska, and the Yukon. There's lots of confusion here. I'm just going to briefly touch on it. I believe it adds support to the model. I'm going to talk about what's called disharmonious associations during the Ice Age. It's common that you have animals that love warm climates and those that love cool climates that are fossilized, or I should say buried together in Ice Age sediments. And I'm going to talk a little bit about end Ice Age extinctions. This will be support for the model. I'm going to also end with challenges to the model. The first one is going to be how are ancient Ice Ages to be explained? I'll define what ancient Ice Ages are. Those are the Ice Ages 100 million to over 2 billion years ago, they claim. And recently, ice cores from ice sheets supposedly give old age. Those are challenges to the model. This is the uniformitarian model. Each Ice Age takes 100,000 years. The glacial phase is 90,000 years, while the interglacial phase is only 10,000 years. And there's been 30 regularly repeating Ice Ages during the past 2.5 million years. Now, you might have heard there was only 4 Ice Ages. And this was dogma taught for about 60 years all around the world. Wherever they went, they saw 4 Ice Ages, 4 Ice Ages, 4 Ice Ages. That's all gone. Now they believe in 30, and it's based on deep sea cores. Oxygen isotope wiggles in deep sea cores is where they get the 30 now. Not only that, they claim the Antarctic ice sheet started forming 40 million years ago and reached a peak and has been in equilibrium for 15 million years. And the Greenland ice sheet formed and reached its present height several million years ago. That's the challenge that the uniformitarians give us. What do we do about it? A quote from an anti-creationist, Arthur Strahler: increasing duration of the Ice Age by a factor of 10 greatly increases the stress upon the creation scientist who must compress the events of 15 million years down into 4,000 years of post-flood time. That's the sort of challenges you get about the Ice Age. So, what do we do about it? This has been my theme verse for 30 years. Examine everything carefully. Hold fast to that which is good. You don't start from scratch. You hold fast to the gospel. You hold fast to Jesus. You hold fast to the Bible. But you examine everything carefully. Now, we talked a lot about dating methods, so let's talk about dating methods and get them out of the way right away. And I have a personal reason why I distrust dating methods. I was a weather forecaster for 30 years, and I did this. I ruined thousands of outdoor activities. And because of that, I've become very skeptical of what they say millions of years ago, dates or other events they talk about millions of years ago. We can barely forecast the weather one day in advance. I think that all these scientists that are so sure, I read the geological literature, 90% of it's uniformitarian geological, geophysical literature, and I'll tell you, they are so dogmatic that it's almost as if they were there. They ought to be weather forecasters for 1 year, before they start their careers in geophysics or geology. And I don't think there'd be so much dogmatism. The first question, was there an ice age? Well, when you examine the superficial sediments, the sediments that are on the surface of the earth, in presently glaciated areas, you see a number of features. Now, this is the beautiful Athabasca Glacier in the Canadian Rockies that has been receding. This sign right there, that's where it was in 1890, and yet it has been receding. And when it leaves behind, you can examine what an ice does. It leaves behind rocks of all sizes within usually sand and silt, kind of in a finer grained matrix. It leaves behind end moraines and lateral moraines. End moraines and lateral moraines are formed when the glacier pushes out material ahead of it. And as it's along the side, it's called a lateral moraine. When it's in the front, it's called a terminal or end moraine. Speaking of this, I can't help but make a comment on global warming. Yes, all glaciers of the world have been receding, or mostly all. And yes, it is true there has been global warming, and I believe it is true that man has been a cause of it, but I believe that nature is part of it too, because between 1350 and 1850, we had the Little Ice Age, where all the glaciers in the world advanced. Now we're in the opposite fluctuation where they're receding. So I think this is partly due to the effects of the sunshine and less volcanic ash in the stratosphere, of why we're getting some of the global warming. There's a beautiful end moraine, very sharp looking, made not too long ago, probably made about 1890. Another feature you observe around glaciated areas is scratched bedrock. As the glacier moves over bedrock, it has rocks in the bottom of it, and those rocks in the bottom scratch the bedrock. So it's typical to see striated bedrock, or pavement as they call this. Also, some of the rocks themselves get scratched, and a lot of times they get scratched in different directions. Here's one set going that way, and there's another set going this way, like this. And it's probably because the rock turned a little bit in the ice. The ice is more plastic and malleable, so that's probably why you have striations in different directions on rocks. So those are some of the features we see in currently glaciated areas. So let's extend those to features where it's claimed to have been glaciated. Here's one area where I used to live, west of Great Falls, Montana, near Augusta, Montana. This is the Rocky Mountain front. The Rocky Mountains were glaciated during the Ice Age, and the ice came about 10 miles out onto the high plain and formed this end moraine, just typically is what you see at the Athabasca Glacier. I'm taking a picture of this from this part of the end moraine right here. It was breached right in here. Probably when the glacier melted, it breached through the end moraine right here. So that's why there's a gap there. When you look at the material in the end moraine, it's very similar to glaciers you see today. It's rocks of all sizes in a finer grained matrix surrounding the rocks. Typically, they call that glacial till. Also, when you go up into the Rocky Mountains, you see scratched bedrock going east. In fact, there's an 800-foot cliff right along here. The glacier came up out of this valley, scratched the bedrock, and went down over an 800-foot cliff. Also, you'll find in the moraine that I showed you previously, you find rocks that are scratched in several different directions. Typical what you see in glaciated areas. And this is in an area that gets up in the 80s for high temperatures in the summertime. Also, as you tour around the west, you see that out of some of the mountain valleys of the western U.S., you see moraines, just like you see at the Athabasca Glacier. This is probably one of the best moraines that I've ever seen before. This is the horseshoe-shaped lateral end moraines around beautiful Wallowa Lake in northeast Oregon. It moved out onto the Enterprise Plain in northeast Oregon, about 4,000 feet altitude, where it gets probably a high temperature of 90 as the average in July. There's the lateral moraine, end moraine, and lateral moraine. They're fairly sharp looking, indicating that the Ice Age ended not that long ago. Furthermore, a feature like this could not form during the flood. This feature has to form by other mechanisms, and it's on top of flood sediments, so the Ice Age occurred after the flood. And here's this another picture of that lateral moraine. You can see the trees for scale. This lateral moraine is 600 feet tall. And here's what you see within the lateral moraine: glacial till, rocks of all sizes in a finer grain matrix. And you see these around the Sierra Mountains and other Wind River Mountains of the western United States. Also, you see these erratic boulders here and there. Most of them I see are kind of sub-rounded or rounded. I think that a lot of erratics were transported by water. This one is very angular. This is the famous Okotoks erratic, southwest of Calgary, Alberta. This forms a line of erratics from Jasper, Alberta, down into northern Montana, just kind of a line, and very angular, which means they didn't roll down there. Probably they were deposited by icebergs as ice was melting. Here's another famous erratic called the Bellevue erratic. Now this erratic is, erratic boulder is a boulder rock that doesn't outcrop in the local area. It's been transported somehow. That's what they mean by an erratic boulder, or exotic boulder is another name. This one is found southwest of Portland, Oregon in the Willamette Valley. It's composed of argillite, which is a slightly metamorphosed shale, and the nearest outcrop of that is in northern Idaho. And it's well south of the ice, where the boundary of the ice, by the way. How did it get down there? And it's very angular. The only way you can think about it is on an iceberg. And how would an iceberg take it down there? Well, when glacial Lake Missoula broke, it spread through eastern Washington, through the Columbia Gorge, and spread over Portland, Oregon, 400 feet deep and up into the Willamette Valley. So if there was a glacial Lake Missoula and a Lake Missoula flood, there had to be a thick ice dam in northern Idaho to block up the water in the Clark Fork Valley, indicating again that the Ice Age was a real event. So when you sum it all up, this is the big picture right here. Ice covered practically all of Canada. Just a little bit in the Yukon Territory was unglaciated. It came down in the northern United States to around, they claim, northern Missouri, and I'm not quite sure of that. That's a subject of research, but it got pretty far south of the Great Lakes, and it covered some of the mountain areas as ice caps. But interesting enough, in Alaska, the Brooks Range and Alaska Range, they were glaciated, but the lowlands of Alaska were not glaciated. And that's where you find all those woolly mammoths, bisons, and horses, and lots of animals in Ice Age permafrost in those areas. When you go to Europe and Asia, this is a general feature where the ice was. It covered much of England and northern Germany and Poland, and clear out into northwest Siberia. Now there's a little question on the boundary right in here, and some people think that the ice covered the Barents Sea north of Norway there. So there's still some controversy over the exact distribution of the ice. But when you add it all up, ice covered 30% of the continental areas. The closest ice to this area would have been up in Pennsylvania. Can mainstream scientists explain the Ice Age? If you read some textbooks, some of them make it seem like it's easy to produce an Ice Age. But Let's take a look, first of all, what the requirements for the ice age are to evaluate that. What do we need for an ice age? First of all, we need cooler summers. Most areas where the ice occurred, the winters are already cold enough. In fact, it would help if the winters were warmer. And indeed, I believe they were warmer, as I will tell you later. But you need cooler summers, because it's the summer heat and the sunshine that will melt any snow or ice that from the spring. You got to have cooler summers. You got to have greater snowfall. Not only that, if you can find some climate change to do this, it's got to not just be one summer, it's got to persist for many years. Now, the alternative explanation is uniformitarianism. The present is the key to the past. What sort of present processes are going to cause cooler summer, greater snowfall, and persist for many years? Well, first of all, let's find out how much cooling we're talking about. A guy named Larry Williams did an experiment in which he took the snowfall from winter and spring, and he cooled off summer temperatures by increments of 2 degrees centigrade or 3 degrees Fahrenheit. And he wanted to determine how much cooling he needed for 1 inch of snow to remain by the early fall. So as you see here, this is a change in temperature. This is a change in summer temperature. I'm going to focus in on this minus 12. When it got down to when it was 12 degrees centigrade cooler, that is about 20 degrees Fahrenheit, the 1 inch stayed right in this area, northeast Canada. But in his model, he had 4 features that aid his snow to stay. First of all, he doubled the winter's snowfall. He raised the land 400 feet. He got rid of Hudson's Bay, which is a moderating influence, and he decreased the solar radiation. And still, after 20 degrees Fahrenheit, he only got northeast Canada. If they could find a cooling mechanism, they have another problem. This is a graph of temperature versus water carrying capacity at saturation or 100% humidity. It's the most the air can contain. At these certain temperatures, on this line, you'd have fog. So the average temperature in northeast Canada is 10 degrees centigrade. So if you cool it off 12 degrees, that'd be an average of minus 2 degrees centigrade in summer. Well, look how much moisture decrease. You go from 10 grams per cubic meter down to 4 grams per cubic meter. What does that mean? That means you've dried out the air 60%. So if they can find a cooling mechanism, they end up drying the air out. Just the opposite of what you need for an ice age. That is why in the 1960s, there was over 60 theories of the ice age. That might give you a hint that they can't explain it. It's like there was about 60 theories of why dinosaurs went extinct too. It's because they can't really explain that either. But let's look at a place closer to home, on the edge of the ice sheet, at Minneapolis, Minnesota, that probably had an ice depth of 500 feet over it not too long ago. The June to August average summer temperature in Minneapolis is 70 degrees Fahrenheit. That includes maxes and minimums, average to 70 degrees. Well, you have to at least cool the temperature down to 32, but snow will melt below 32 degrees. In fact, quite a ways below 32, you'll have net melting in the warm season. In Antarctica, they noticed that when the temperature warms up to 14 degrees Fahrenheit in the spring, you start melting the snow. Up to 14 degrees. Well, I'll be a little more conservative. I don't think, well, they probably were cooler than 14, but I'll be conservative and say that summer temperatures must drop to at least 20 degrees Fahrenheit for an ice. So that's a cooling of 50 degrees Fahrenheit for Minneapolis. Can you think of any present climatic processes that are going to cause a cooling of 50 degrees Fahrenheit in the summertime? I mean, you can't even think about it. So that's why the Ice Age, instead of being a showcase for uniformitarianism, is a serious, serious problem. And I'm going to just run a bunch of quotes by you. I can dig up a lot of these. Here's one from J.K. Charlesworth from his monstrous 1,600-page book called The Quaternary Era. He says, Pleistocene phenomenon, that means, when you say Pleistocene, that means Ice Age. Think Ice Age phenomena produced an absolute riot of theories, ranging from the remotely possible to the mutually contradictory and the palpably inadequate. That's not saying much, is it? Well, let's get one closer to our time. In the defunct popular Earth Science journal called Earth, 1996, Daniel Pennick said if they hadn't actually happened, the ice ages would sound like science fiction. They see the signs all over in the northern hemisphere at high and mid latitudes. So it happened. But if they weren't there, if someone said there was an ice age, it would be like science fiction. Recently, in 1997, U.S. News and World Report reported on 18 great mysteries of science. One of them is what causes ice ages. 18 great mysteries of science. One of them is what causes the ice age. And just recently, David Alt from the University of Montana at Missoula says, in glacial Lake Missoula and its humongous floods, by the way, I only think there was one Lake Missoula flood, but anyway, in that book, 2001, he said, although theories abound, no one really knows what causes ice ages. So, the ice age is not a showcase for uniformitarianism, it's a monstrous, huge mystery. Can we explain it? Well, I believe we can. First of all, we can tell from the clues that it's post-flood. It's on the surface of flood sediments, and we definitely don't have it today in the present climate. The ice sheets in Canada are gone. So it must have happened in a transitional climate from the flood to the present climate. Well, that means the flood could have caused the ice age. Well, indeed, I believe that is the case. So let's see how the Genesis flood fulfills the requirements for an ice age. Well, the flood was a giant volcanic tectonic event. Tectonic is crustal earth movements. But at the end of the flood, you have a huge shroud of volcanic dust and aerosols. Aerosols are fine particles about a micron in diameter. They would be floating on the stratosphere. What they do, what we know from modern volcanic eruptions, they cause cooler temperatures, especially in summer and over the large land masses. So after the flood, you'd have so much volcanic ash and aerosols that you'd cause a pretty good cooling right off the bat. Also, the fountains of the great deep and volcanism cause a warm ocean. There's lots of ways to cause a warm ocean in any flood model, but the fountains of the great deep imply that there was water trapped in the crust, and it came up, and at the end of the flood, that warm water coming from the crust would have been added to the current oceans, resulting in a warm ocean from top to bottom and pole to pole. You could probably swim in the Arctic Ocean right after the flood, it was so warm. There'd be no sea ice. Anyway, the significance of the warm water is that the warmer the water, the more the evaporation. In fact, at 86 degrees Fahrenheit, you would have 7 times the amount of evaporation of water than at 0 degrees centigrade or 32 degrees Fahrenheit. Huge amount of evaporation with warmer water. Also, the mechanism is going to persist, but it's going to wane with time as the volcanic ash settles out and the earth settles down to equilibrium and the oceans cool. Particularly the oceans cooling is the key for the waning of the ice age. Here's kind of a schematic of how this would work. The volcanic dust and aerosols would reflect some of the sunlight back to space, cooling the surface of the earth, mainly the land masses at mid and high latitudes. Now, volcanic ash and aerosols filter out of the atmosphere, sink out of the atmosphere in about 1 to 3 years. So you have to keep replenishing the stratosphere after the flood. And indeed, there's a tremendous amount of ice age volcanism in ice age sediments, indicating we had tremendous volcanism for quite a while after the flood. Now, they know that uniformitarians notice that, and they know volcanism causes cooling, but you know, when they stretch out the ice age into a 2 million year period, it's nothing. But when we telescope it into a short time scale, it becomes very, very significant. Now, with basic meteorology, you can guesstimate, that's meteorological jargon, the storm tracks during the ice age. Storm tracks would be in areas where you have strong horizontal temperature differences. And where would they be? They would generally be between the cold, cool land and the warm ocean. So you'd have a storm track parallel with the east coast. Also, another storm track would be cold ice sheet and a little bit warmer land here, so you'd have a storm track just south of the ice sheet. And storms would generally follow these. Now, these are general storm tracks. In meteorology, chaos usually rules, so These are just general. And most of the time, precipitation in wintertime storms falls on the north side of the storm. So it'd fall right in there where the ice was building up. In this schematic, this is where the ice is still building up. Also, you can figure out where the main evaporation areas are. Generally, with west-east flow, you have fairly drier, cooler air from the continent going out over the warmer ocean. That produces strong evaporation on the east coasts of continents. And of course, in Arctic Ocean, close to the land, you'd have strong evaporation. Those are close to the areas at the mid and high latitudes where you want it to evaporate. It's close to where the building ice sheets developed in Canada and the northern United States, and of course Scandinavia. Then the next question, how rapid was the ice age? How rapid was the ice age? Well, here's my main proof that it was indeed rapid right here. This is it, Jenkins, indisputable proof that the ice age caught these people completely off guard. Well, more seriously, the way I calculated it, I used what's called heat budget equations for the ocean and atmosphere. See, it's the cooling of the oceans that control the ice age. With that strong evaporation, you have a lot of precipitation, but with a cooler ocean, precipitation decreases, and finally it quits building up the ice sheet, and finally it starts melting. So you simply add heat inputs minus heat outputs equals a change in temperature. It's like this room right here. If we turned on the heater and the air conditioner, you'd have a heat input and a heat output. And whatever one wins is your change in temperature with time. There's a time factor in that, and therefore you can get a calculation of time. So that's how I did it. But there's no way to be accurate in this. So what I did is I used minimums and maximums for the variables in this equation. By the way, the strongest variable for heat output or cooling of the ocean is evaporation. Evaporation is a really strong cooling mechanism. So, not to tell you about the details and cause some of you to fall asleep, I'm going to just give you the big picture. The time to reach glacial maximum, the minimum was 297 years and the maximum about 1,700 years. A best estimate is about 500 years to reach glacial maximum. How much ice and snow did we collect in that time? Well, that's based on how much evaporation, how much input you have from low latitudes, how much falls on the continent versus the ocean, and other variables like that. So using minimums and maximums, you can see the ranges I got. And the best estimate is about 2,300 feet or 700 meters average in the northern hemisphere. And there's the corresponding estimates for Antarctica, about 4,000 feet in Antarctica. Now, these are averages. Some areas would be thin, like up in Montana and Alberta, near where I live, the ice sheet was quite thin. Because some of the mountain areas, like the Sweetgrass Hills in northern Montana, were sticking up out of the ice. And the Cypress Hills of Canada, the western Cypress Hills were up above the ice also. So it was very thin. I think in New England, which is close to the storm tracks and the warm ocean, it was probably pretty thick in the New England area and southeast Canada. Then we need to melt it. How fast does it melt? I used the energy balance over a snow cover. The main mechanism to melt snow and ice is solar radiation. And that's why snow and ice can melt even below freezing, is because of solar radiation. And when you melt it usually from the top down. And a lot of times you find rivers flowing on the ice. And a lot of times it'll sink down into the ice until it hits a frozen layer. And a lot of times, sometimes it'll refreeze there, or sometimes it'll pond there. Sometimes it'll flow through cracks and go to the bottom of the ice sheet and pool along the bottom. And sometimes that'll cause what's called surges of the ice. So what does that say? Well, I used ranges, and those are the ranges. The best estimate is 70 years to melt the edge of the ice sheet in the northern hemisphere. That's a rate of 10 meters a year for 700 meters. It melted in about 70 years. Now, 10 meters a year is about 33 feet, and that compares very well with the melting area on glaciers in Norway, Alaska, and Iceland. So it's a very reasonable figure. 70 years to melt the edge, and then you go to interior Canada where you have less solar radiation, and usually the reflectivity of the snow will be higher there, so it'll take a little longer to melt it in interior Canada, so it'll probably take around 200 years. So the total time for the post-flood ice age is approximately 700 years. We do not need 100,000 years for an ice age. This is a case of using different initial conditions from the Bible, from the flood, and you get totally different results. Multiple ice ages are mainly an assumption, because most areas on land where you look at the glacial till, it gives evidence of only one ice age. In fact, just recently, here's a reinterpretation. They used to think there were 3 or 4 ice ages in Alberta, southern and central Alberta. And this was published in the Journal of Geology. And notice the title. It says, a single late Wisconsin Laurentide glaciation, Edmonton area in southwestern Alberta. A single one, and they believe it's late Wisconsin time. There were none of them before that. They just believe in one ice age now. And notice what they say. Glacial reconstructions commonly assume multiple glaciation hypothesis in all areas that contain a till cover. In other words, it's simply an assumption. And there are areas where you could say that it could happen, but you know, with a fairly warm ice age, which the post-flood model would occur, you'd have the ice moves faster when it's warmer. You can have pretty dynamic ice age and surges. One surge and then another one. You can have different till sheets formed by those surges with different deposits between those till sheets, all in one glaciation. They used to think those were due to multiple glaciation. Will there be a future ice age? Well, why do they say that? Well, here's Daniel Grossman, New York Times, just recently. If the past is any indication, the Earth is at the end of another such warm period, poised to descend into a new ice age. Well, when? Well, how many saw that movie, The Day After Tomorrow? Well, according to that could happen almost any time, right? Well, why do they say the next ice age is due soon? Well, we're still in the glacial-interglacial ice age cycle. Interglacials only last 10,000 years. The last ice age melted 10,000 years, so we're due any time. It's kind of interesting that in the 1970s, we had a little cooling trend away from the general global warming, and you should have seen the articles and books that said the next ice age is coming. I got 3 of them. It's really interesting to go read those after the fact now, but what happened, it fizzled out and we're back to the global warming again. So the next ice age is due soon. And if the day after tomorrow is anywhere close, it could happen any time. In fact, the message of that movie was that global warming is going to cause the ice age. You know, I could see some of you really sweating about this. I mean, all you that live in the northern United States and in Canada, man, your land values would go down in a hurry, wouldn't they? But you can rest, relax. The rainbow promise, God said He's never going to cause a global flood. And if He's not going to cause a global flood and the flood caused the ice age, there will never be another ice age. You can relax and forget about it. There will never be a future ice age. Now, I want to point out some important features of the ice age model that I've picked up over the years. They wonder, well, what about winters? Well, we'll have cooler summers, but in this model, we're going to have warmer winters, and I will tell you one reason why here pretty soon when I show a diagram. Also, the ice sheets develop in place. They don't move down from northern Canada at a glacial pace. It's suddenly like instant winter. And they develop more or less in place. But they'll generally move south because a glacier moves generally by the slope of its surface. And the slope will be going down towards the south, so it'll generally be tending to move south. So your striations of bedrock will generally still be south. But generally, the ice sheet develops in place. Also, the ice age would develop immediately after the flood in favorable areas. But some areas it would delay. Why? Because you have all this warm water. And onshore flow will keep a place warm. For instance, I believe the United Kingdom probably glaciated fairly late because you have surrounded by warm water and it would keep the ice from building for quite a while. Now here's one of the reasons I believe winters are warmer. This is a model study of a guy who, all he did was he took off the ice cap from the Arctic Ocean and left the temperature of the water at the freezing point of seawater, which is 28 to 29 degrees Fahrenheit. It's lower than 32 because of the salt in the water. And he ran the model, and these are the change in winter temperatures. And these are in centigrade, by the way. At the North Pole, 40 degrees centigrade warmer, which is about 70 degrees Fahrenheit warmer in wintertime, just by getting rid of the sea ice. Why? Because the sea ice reflects sunlight back to space, and it caps the Arctic Ocean so you don't add any heat from the water. And notice that here in Siberia, right here, in northern Siberia, it's about 20 degrees centigrade, which is about, 36 degrees Fahrenheit warmer, right there in northern Siberia. So winters would be warmer during the Ice Age. Now I'm going to go on to support for the model. There's lots of evidence for wet deserts, and I'm going to show you a diagram and a picture coming up, but the evidence shows that the dry areas about 30 degrees north, like the southwest United States, the Dead Sea area, Australia, lots of places were once much wetter. Here's a plot of what's called pluvial lakes in the southwest United States, right in this area. Now, this is just in the Great Basin. There was lakes down in here. Death Valley had a lake about 600 feet deep. This is Lake Bonneville, which is a Great Salt Lake about 6 to 8 times as large, 800 feet deeper. By the way, the average depth of Great Salt Lake today is only 15 feet deep. It was 800 feet deeper during the Ice Age. Now, uniformitarians, how are they going to get a climate change to fill these things up in those areas? It is very difficult. But like I said, in our model, we fill them up first. As the flood drains off, it'll fill up pockets or basins in the land at the end of the flood. And by the way, if you've ever been to these areas, there's beautiful, large shoreline features along this Lake Bonneville here, shorelines and high deltas. If you land at Salt Lake Airport, look out the window along the foothills and you see the shorelines. There's two distinct shorelines. In fact, I found shorelines around this lake. It's called Lake Lahontan. Today, you just have a few shriveled remnants of that lake. These lakes right here, they get up to almost 100 degrees now in the summer. I've taken pictures around there. There's a Mono Lake there, Glacial Lake, Mono Lake, and then Death Valley. There's shorelines around Death Valley. Quite a different climate during the Ice Age, a lot wetter. Now, it's interesting that the Sahara Desert was much wetter. Man lived in the Sahara Desert by the thousands, and he has all kinds of rock art. This is a picture of a giraffe on a rock in the Sahara Desert. And I'm going to just summarize a quote from the book, The Great Sahara. The Sahara is a veritable art gallery of prehistoric paintings. The evidence is enough to show that the Sahara was once a well-populated area of the prehistoric world. Yet, there is man's work in the most inaccessible corners of the desert. Literally thousands of figures of tropical and aquatic animals. Yes, aquatic animals. Enormous herds of cattle, hunters armed with bows and boomerangs, and even domestic scenes of women and children in the circular huts in which they lived. Why would the Sahara be much wetter during the Ice Age? Well, because you had a huge amount of evaporation right after the flood. The lowlands of Siberia, Alaska, and the Yukon were unglaciated, and this is a mystery. And here's a plot of the mountains being glaciated, and the lowlands, which are in yellow there, are unglaciated. By the way, most models of the Ice Age have extreme difficulty forming the Ice Age. Extreme difficulty. Now, some will produce it, but a lot of times it's because those models are tweaked to produce it. Anyway, Phillips and Held said in the Journal of Climate, Siberia and Alaska, well, they said, we now have glaciation. They did produce glaciation, but unfortunately, it was outside the areas where it existed during the last Ice Age. And that included the lowlands of Alaska, Siberia, and the Yukon. In other words, those lowlands like to glaciate. Why weren't they glaciated in our model? It's because of all the warm onshore flow. Mainly, it was the onshore flow that kept it ice-free. Now, the woolly mammoths in Siberia. What were millions of mammoths doing in Siberia where they couldn't live today? mainly because it's boggy, they can't get around, and the bog vegetation is toxic to them because they ate grass. Not only was the woolly mammoths in Siberia, you had woolly rhinoceros, horse, bisons, a lot of different animals that lived in Siberia during the Ice Age. So what's going on? Why these sorts of things? Well, first of all, you got to determine whether the mammoths died during the flood or during the Ice Age. I think from what I've seen, from studied, it's overwhelmingly they died at the end of the Ice Age. One of the main evidences in northwest Siberia, you find woolly mammoth skeletons on top of glacial till, which means that as the glaciers receded from northwest Siberia, the mammoths came up in that area, and then they died on top. So they died at the end of the Ice Age. That's the distribution right there, all across the northern hemisphere. In fact, you don't find them in areas where the ice lasted the longest, which is much of Canada and northern and central Scandinavia, which is what you'd expect during an ice age. And during the Ice Age, they would be able to migrate over a Bering Land Bridge. Now, as the snow piles on land, it evaporates from the ocean, the original water, and the sea level drops. And the Bering Land Bridge is very shallow, so man and animals could easily migrate into the United States and down through an ice-free corridor. They came down here and spread through into the southern United States, Central and South America. Now, a good indication that the climate was quite different during the Ice Age is the distribution of the saga antelope. The solid line there represents the current distribution of the saga antelope, and the dashed line is the historical. Their range is shrinking. But those dots represent Ice Age distributions. You can see them up in northern Siberia. What's so significant about that? Well, the saga antelope has thin hooves, and it likes wide open spaces, plains, and can't negotiate permafrost and swamps very well, indicating that this area was totally different ecologically during the Ice Age than it is there today. During the summers, it's quite a swampland because of the melting of permafrost. Permafrost melts that much, and it has nowhere to go, and so it ponds, and then you get all these plants growing in there, and it becomes a bogland. And it's hardly any animals can live there today in those areas. This is indication that we very likely had no permafrost during the Ice Age. Now, the uniformitarians, I think, have not really faced this problem because they grudgingly might say, well, maybe it was a little warmer climate, but some say, hey, it was during the Ice Age. It had to be a lot colder in Siberia. And they say, oh, that would solve the problem of those bogs. It'd freeze the bogs. Well, if it freezes the bogs, what are they going to eat? So let's kind of sum up what postulated Siberian temperatures. And by the way, this applies also for other areas of the northern hemisphere. I believe at the end of the flood, you didn't have much seasonal contrast. Summers were cooler, winters were warmer. But as the Ice Age continued, it cooled off, and you had more extremes occur. This is the Ice Age framework right here. So at the end of the Ice Age was probably your coolest time. Also, because of all the warm temperatures around, you probably had heavy precipitation in most areas of the world right after the flood for quite a while. So you start with, in Siberia, as well as elsewhere, pretty heavy precipitation. And it's probably a forest land for quite a while in Siberia with that much precipitation. But as it was getting a little cooler, it was drying out. I think the woolly mammoths moved from the south up into this area, along with horses and bisons and woolly rhinos and all kinds of other animals, about this time when it started to dry out. Finally, it dried out more and more and more, and by the end of the Ice Age, it was very dry, and it's recovered since. This is the postulated area of Siberian permafrost. There was no permafrost at the end of the flood. There would be no time for permafrost. Forms from freezing temperatures from the surface down. After the flood waters drained, there couldn't have been, just by definition. But I believe the permafrost probably didn't develop for quite a while, and towards the end of the Ice Age, or near glacial maximum, it started to develop pretty good, and it really developed a lot as the glaciers were melting, like this, and then it's recovered since then. And here's a woolly mammoth timeline, whether you start with 2 elephants that leave the ark at the end of the Ice Age are two woolly mammoths. I believe it was two elephants, and the mastodons and mammoths are part of the elephant kind. But regardless, they're going to grow slowly. They grow slowly, and then finally when their population is going to mushroom by geometric progression. Yes, you have plenty of time for millions of mammoths in a 700-year Ice Age. Finally, towards the end of the Ice Age, the climate changes. It's a dynamic climate. It becomes colder, drier, and windy, and they go extinct at the end of the Ice Age. This is the famous Beresavaca mammoth that was towed out of northeast Siberia, and that's generally the position they found him. It's in the St. Petersburg Museum in St. Petersburg, and it had a broken foreleg, it had broken ribs, broken pelvis, and it was in a general standing position. The question is that really plagues most people is, how did these animals die? Well, I believe the solution is found in the deposits surrounding the mammoths. Let's take a look at what they're buried in. Are they buried in bog, with bog material, river material? Some are in those, I think, but the mass majority of them are in windblown silt. This is a recent quote from a book called Mammoths and the Mammoth Fauna. A particular interest for paleozoologists is what's called the odama. The odamas are hills that are formed after permafrost melts around it and then leaves some permafrost as hills. This is actually a loess layer, that is windblown silt, as a rule containing the largest amounts of remains of late Pleistocene animals. They're buried in windblown silt. So what's the picture here? Well, I believe they died in large dust storms, sort of like what happened in the Dust Bowl era. This is a picture from the Dust Bowl era that if you were in a dust storm, you would see just a cloud of this dust coming, and the visibility would go down to zero. There might not be any wind right before it. It'd be like with a cold front. Sometimes there's no wind ahead of a cold front. And suddenly, the winds just really pick up, and the visibility drops to zero. And dust drifts, talk about dust drifts. During the Dust Bowl eras, dust drifts covered up fences, machinery. This one is up to the tops of a house. And by the way, I believe that the amount of windblown silt in those areas of Siberia, some places is over 100 feet thick. So I believe you had worse dust storms up there in Siberia than you did in the Dust Bowl era. They might ask, well, why are we going to have late Ice Age dust storms? Well, because of colder winters, colder oceans, which means more sea ice, which also means a drier atmosphere, and stronger north-south temperature differences, all resulting in a lot stronger winds and dry, cold fronts, a lot drier, cold fronts. So here's the big picture. Woolly mammoth, peacefully eating grass and buttercups. Yes, buttercups. The reason we have those is because they were in his mouth and in its stomach, half decayed. The digestion of a woolly mammoth doesn't occur in the stomach. It occurs after the stomach, by the way. I think that's a key to why the vegetation's only half decayed. But anyway, the winds come up. Uh-oh, he's going to ride it out. Guess what? He ends up like a snow fence. And what happens to snow fences? The snow piles up around it. The dust would pile up. He's starting to suffocate. And he's in a standing position. He tries to get out, and he breaks his right arm leg bone, because it appears that he was alive when that front leg broke. And by the way, there's an analog for this in Hot Springs, South Dakota, where some of the mammoths that fell into that sinkhole, they've excavated 52 mammoths in Hot Springs, South Dakota in a sinkhole. Some of them have broken forelimbs also, that the researcher there thinks it was because they're trying to get out of the mud. In this case, the dust packing up would be almost like concrete. Finally, other dust storms totally cover him up. And he ends up in a standing position in the dust. And how do you get him in the permafrost? This has always been a major question. One person said, do you jam him into the permafrost? No, the permafrost in this case will come up to meet him. And by the way, permafrost also shifts and faults once you get it up there. And the faulting can break the pelvis of the Beresavaca mammoth and its ribs. So in a nutshell, that's the story of how I believe they went extinct. Also, something called disharmonious associations. They find, as a rule, you have animals that love the heat and love the cold that were buried in Ice Age deposits together. In the book Quaternary Extinctions of Prehistoric Revolution, it said the late Pleistocene communities, that's Ice Age communities, were characterized by the coexistence of species that today are allopatric, translated, not climatically associated, and presumably ecologically incompatible. Disharmonious associations have been documented for late Pleistocene Ice Age floras, that's your plants, terrestrial invertebrates, lower invertebrates, birds and mammals. In fact, it was common. And that's exactly what you expect, because this distribution would occur with cool summers and mild winters. While in the uniformitarian model, you have cold winters, period. You shouldn't expect that. One of the most outrageous instances is in England, where you have 100 associations of hippos with musk ox and reindeers in the same stratigraphic layer. How do hippos get up there during the Ice Age? Well, because I believe Britain was warm with a lot of warm onshore flow for quite a while and very wet, very heavy precipitation. So the hippo, after the flood and leaving the ark, would find it congenial up in there. And finally, as the temperatures cool off, he found himself in the wrong environment, and he was being populated by reindeer and musk ox and woolly mammoths. And finally, they all died. And were buried in what it says here in this quote, in stratigraphic context, it seemed to indicate contemporaneity. In other words, they died at the same time. Also, they found out that when things were supposed to get better at the end of the Ice Age, it was warming up, the ice was melting, suddenly all these large animals disappeared on whole continents or went extinct all over the world. End Ice Age extinctions. 100 species of large animals in North America, that's 70%, died at the end of the Ice Age, including the horse and the camel. Europe and Asia lost 75% at the end of the Ice Age. Australia lost 90% at the end of the Ice Age. Why? Well, I think it's the same reason they were lost in Siberia. It was colder, drier, and windier. I think the dust storms, which there's lots of evidence, was a prime factor in the extinctions at the end of the Ice Age. Here's a quote from a recent book. After many decades of debate, the North American end Pleistocene megafaunal mass extinction remains a lightning rod of controversy. The extraordinary divergent opinions expressed in this volume show that no resolution is in sight. I would say it can readily be explained in the post-flood Ice Age model. Now, I'm going to quickly go over some challenges to the Ice Age, and that's called ancient Ice Ages. They claim in the solid rocks we had Ice Ages that lasted sometimes several hundred million years in the late Paleozoic, late Ordovician, late Precambrian, and the mid-Precambrian. 4 of them. And by the way, this late Precambrian one, since the deposits are found at low paleolatitude and they're marine, they believe now that the Earth was totally covered in ice at least once or twice in the late Precambrian at the time when life is supposed to be evolving, before the Cambrian explosion. Big problems. It's called the snowball Earth. Anyway, they do have evidence for these so-called ancient glaciations. This is late Paleozoic deposit in South Africa called the Duica-Tillite. You do see they do have scratched bedrock, and here's the till-like material that they call tillite. So they do have evidence. And we're challenged on this by people like Arthur Strahler, who said the Carboniferous tillites cannot be accepted by creationists as being of glacial origins for the obvious reason that the tillite formations are both overlain and underlain by fossiliferous strata, which are deposits of the flood. During that great inundation, which lasted the better part of 1 year, there could have been no land ice formed by the accumulation of snow. He's right. We're not going to have an ice age during the flood. The flood was, if anything, was a warm event. So how do we explain it? Well, he not only challenges, but Davis Young, professor of geology at Calvin College, also says this. Thus, once more, we find abundant evidence in nature of materials that require much more time to form than that which is allotted to us by the one-year flood. He's referring to the tillites, to the so-called ancient ice ages. So there's lots of problems with them, and I'm just going to mention 2 of them. One of the main problems is these tillites, which are consolidated tills, are a lot of times they're associated with warmth indicators like dolomite. Dolomite forms in generally a warm environment, and they're next to these tillites. Another problem is that their deposits are practically all marine. Maybe we ought to be thinking of a marine mechanism for it. Well, do we have an alternative explanation? Yeah, I believe we do. Giant landslides. Some of the other speakers have mentioned landslides. I believe we had tremendous landsliding during the flood. Here's a landslide deposit. It's called a debris flow also. And it happens to be on the top of a mountain range in Montana, the Gravelly Range. And it's got a till-like features with rocks of various sizes and a kind of a finer grain matrix around the rocks. And it's interesting that this deposit moved and it scratched the bedrock. Like here's some of the scratches. Here's the material right here. Here's some of the scratches right in here. Here's another picture of it with the scratched bedrock, the landslide material, and a little scratch on a boulder. These would obviously be glacial features to many, but yet this is a landslide feature. The challenge of ice cores. The Greenland ice cores are claimed they detect annual layers to 110,000 years, like counting the rings in a tree to determine the age of the tree. To 110,000 years. I've gotten a lot of email over this by Christians and creationists that say, man, we have to accept this. I mean, it's, that's like, tree rings, that's very scientific. Oh, there's another story to it. Also, they just recently determined that the Dome Sea core, they've now reached 900,000 years. What about these things? Well, first of all, as ice deposits on the ice sheet, it tends to, as more and more piles up, the layers get stretched out horizontally and thinned vertically. Now, the amount of thinning depends on how old the ice is. And this is where the problem becomes, because they believe that the ice sheets are old and been in equilibrium, so it's pushed down the ice to, by the time you get down to the bottom, they're paper thin, like this. They're as thin as paper down there. Well, we would expect that they start building up in the flood rapidly, and at the end of the flood, tailing off to the present equilibrium distribution today. So our annual layers, their annual layers are like this, right here, about 0.2 or 0.2 of a meter. And as you get deeper, this is in the GISP-2 core in Greenland, which is 3,000 meters deep. They become paper thin as you get down in there. They believe that. But in our model, the layers are probably 6 meters thick and have been compressed some. They all compress, but they haven't had time to compress much. And the annual layers are a lot thicker, so they compress down to 3 meters or a little less. So that's quite a difference, 3 meters versus a few centimeters. So we got quite a difference right in there. So who's right? This is the core that they take those on. This is called as the GISP-2 core. They date those annual layers down to here. You might notice that, look at all those fluctuations. This is, to make a long story short, is the Ice Age portion of the core, right down in here. And there's huge fluctuations in the variable that determines temperature. And that's what's given them the idea that we have abrupt, quick climate changes. And there's a whole new paradigm in climate now where they're talking about these abrupt changes. And that spawned the idea of the movie The Day After Tomorrow. But they've counted them down to right here. But why can't they see that the annual layers that we believe are there, why can't they see them? I believe they're there. Well, it's a common in science, and I picked this up just in a book that had nothing to do with the creation evolution issue. It's on the sleep research. Dr. William Demmett says, even when they are looking, people usually see only what they expect to find, and that they do not see what they assume, for whatever reason, could not exist. In other words, their paradigm is thinking old age, old age. And you know something? That's what they see. It thins very much at the bottom, and that's what they expect. So they don't see it. Well, how come they can miss it if the annual layers are a lot thicker? Well, here's two variables. At the precip rate, it was 20 centimeters of ice a year, which is the current precip rate at the top of the Greenland ice sheet. You usually have storms and other climatic cycles throughout the year that cause quite a variation like that in what's called oxygen isotope ratios. It's kind of a proportional to temperature. So after time, it diffuses out, all those things diffuse out, and you get a nice annual layer. This would probably be the winter layer, and this would be the summer layer. But if the precip rate was 2 meters a year, those layers would not diffuse out. And they would go in there and count every single one of these layers as an annual layer when actually this was deposited over 1 year. That's one way I believe they are counting a lot more annual layers than are really there. Furthermore, when they first counted down to near the bottom of the Greenland ice sheet, they got an age of 85,000 years and not 110,000 years. And other researchers said it didn't agree with deep sea cores, so you're wrong, go recount them. And you know what they did? The counting mechanism they used, they went from a resolution of 8 millimeters to 1 millimeter, and as a result you pick up a lot more wiggles. And every wiggle is counted as an annual layer. So in these 10 annual layers here at 8 millimeters resolution, they get the resolution down to 1 millimeter and you see a lot more wiggles. And here's the annual layers, a lot more. And guess what? They found 25,000 more years in the bottom 300 meters. And presto, it all agreed. So to make a long story short, I believe that they assumed it old, and that's exactly what they got. So in summary, the recent ice age was real, and it's a mystery for the present processes over millions of years model. Noah's flood caused the transition climate for an ice age. And the ice age itself is strong evidence for the flood and the reliability of the Bible. Ice age lasted 700 years. We don't need 100,000 years. There was only one ice age, and there will not be a future ice age. Much data of the recent past supports the post-flood rapid ice age. Ancient ice ages are actually gigantic submarine landslides during the flood. The Greenland and Antarctic ice sheets are young. Only the Bible ultimately explains the ice age because of the flood. In concluding thoughts, if mainstream scientists can't explain the most recent event in Earth history, the ice age, why should we trust them for older events? If they can't explain the last major geophysical event. The ice age is an example of what can be done with other challenges to the Bible. I believe bringing the flood back in our thinking solves at least 80% of those time challenges. And I found also that time is not a side issue, but the short time scale is a key, I believe, in solving mysteries of the recent past. And that's it. Thank you.